lot going on. It seems like the markets are trading forward.
Yeah, I wonder whether or not markets are trading more because of this debate or because, and eventually the election or the stimulus plan.
Yeah, stimulus, that's the big question mark. We were told earlier that negotiations...
So the question is, will it play? Will the 1920 kit radio come back to life? It's been on my mantle for almost 20 years. It's going on 95 years old. I was asked to take a close look at this 3-tube regenerative receiver that I acquired some time ago. I have never attempted to power this up or really to study it or figure out what the schematic is. It was something that was picked up at a garage just a few houses down. It looked really interesting as just something to sit on the mantle, and it has no identifying marks on it, no name tag, no manufacturer, nothing that I can find on the set at all. This is not totally unusual in 1920s radios. There are quite a few radios that were considered to be kit radios, and by kit radios they were able to skirt many of the patent and competition type rules and lawsuits that were flying around in the 20s. By putting a kit together, you could skirt a lot of that. Plus, it was less expensive for the person who wanted a radio to buy a kit and either assemble it himself or have his friendly neighborhood radio nut assemble it for him. Some of these early radio shops made a point of offering these kit radios and building them for the prospective radio listener. I think this is one of those sets. There were several companies that were offering kits, and they all are very similar to some of the early Crosley regens, which are a regenerative stage with 2 audio amplifiers. So we'll take a look inside. This uses the 01A tube, so I would place the vintage on this radio somewhere between 1923 and maybe 1926. The radio has 2 major controls. First, it has this control, which operates a variometer, and we'll get into that a little bit later. Then over here we have the main tuning control. The main tuning control is a variable capacitor. If I had to guess looking in there, it looks to be about a 400 picofarad cap. And that's got 3 interesting controls here. We'll take a little closer look at those controls. Also peeking in, we can see there are 3 tubes. One's a little taller than the others, but they're all 01A type tubes. Probably 201As. I can look at them a little closer. Again, I haven't even played with this radio at all to tell what I have in it or what the condition really is. Let's take a look. This is a pretty good look inside. We can see that the main coil over here, we have this variable coil, and if I had to guess, I would think that is the feedback coil. Then we have a basket weave wind here, which I believe is the secondary coil or the main tuning coil. And then on the very outside we have a stiff coil, and that stiff coil appears to go to this terminal here. So I believe that is the input or the primary coil. So we have the primary around the outside, the secondary inside, and then the regenerative feedback as a variometer in the middle. So that's a pretty complicated, very high Q front end for a broadcast type receiver. It'd be very difficult to build something like that yourself. Tells you the quality of the components and the type of performance they must have gotten out of a set like this. I can see the grid leak resistor and capacitor right down here. So that must go to the grid of the first tube, which is the detector. Now, you can just see the side of a transformer here. This is the first transformer after the first stage. We go into the first audio amplifier, and then there is a second interstage transformer, and then the final amplifier, which drives the speaker. There is no third transformer. The speaker, or headphones, in this case, was expected to be a high impedance device. A high impedance horn type speaker might have a few thousand ohms of impedance, and it could be connected directly to the plate of the tube. Okay, just listening to a little bit of 160 meters. So the first thing we want to do with this radio, other than, dusting and cleaning and putting a little paste wax on just to shine it up a bit, is test the tubes. But it does not list the 01A or the 201A. This is actually an Arcturus UX 201A, and it's not listed. However, they do list the Type 30, which is a very similar tube, except it has a 1.5 to 2 volt type filament, not a 5 volt filament like the 01A has. So all we're going to do is use the Type 30 settings, but instead of using the setting 2, we use setting 5 on the Princeton. I'm sorry, on the Precision, not the Princeton. 5 volts on the Precision with the Type 30 settings. Lights up the tube, and it's reading good. So that's how you test an 01A. Just pretend it's a Type 30 and increase the filament to 5 volts, and good enough. So two of the tubes in the radio are the short pin triodes, which fit in the socket along with the long pin later 01As. Two different styles of pins. Doesn't slow down this socket because they put the bayonet adapter at a different height on the tube, so either tube will go into the sockets. It's really interesting. But my tube tester certainly would not test those short pin bayonet styles, so I had to improvise by using some alligator clips, and I'm testing the tube using kind of a non-conventional method. But this Cunningham 201A tube, it's one of it's a C301A. Wow, that's a real vintage tube. So it's testing good, so let's check the other one too. Make sure all 3 tubes work. Okay, here's the final tube. This tube was in the detector spot in the regenerative receiver, and it's lighting up, which is good. Off the scale. Well, okay, it's reading, but it's fading a little bit. But it's good. So that's the one we'll use as the detector. These tubes have not been lit up in God knows how many years. And I'm sure that the filament needs to be run in a little bit. A lot of times these tubes do need to be lit up for a while for the filaments to reform, and for the gases in the tubes to stabilize. So I'm going to let this one go for a little while in the socket. We'll see if it stabilizes. But good news, all 3 tubes are showing good on the tester. Again, we're using the Type 30, but instead of 1.5 or 2 volts, we're putting 5 volts on the tube. So I let this last tube, which is the detector, the unmarked tube, burn in for about an hour, and on the tube tester. And it seems to have stabilized now. So the initial readings being unstable, I think it was just the filament burning off with this tube. I think there's no leakage, and I think it'll work fine as a detector tube in the regen. One thing I learned from my shop teacher in high school who was an avid antique radio collector, was that one of the first things that goes bad on these old sets when you acquire them, that you have to repair almost immediately, are the Interstage Transformers. The windings will open up and now you're stuck. You either have to figure out how to rewind the transformer, or you have to find a parts unit and salvage the transformer. So the first thing we're going to do is we're going to check with an ohm meter the primary and secondary of the Interstage Transformers. Okay, we'll start with the transformer that's closest to the detector. Go on this side. There's some terminals. Looks like a 1K. And now the secondary. $6K, almost $7K. So again, the primary of the second transformer, 1.1K, and the secondary, a little over 5K. So these are step-up transformers, typical for interstages. They're normally 1 to 3, 1 to 4, or 1 to 5 in impedance step-up between stages. The grid is always a higher impedance than the plate of the preceding tube. So while we're here, we probably should measure the impedance of the grid leak resistor, which might be open or a very high impedance. Let's just back this off so you can see the meter. I'll try to get on that grid leak resistor. It should be something between 1 and 10 megohms. Let's get in there. These things were always removable. Almost had it. Okay, it looks like about, I had it as low as 3 megs, 3.4 megs. 3.4 megs on the grid leak resistor, which is not surprising. That's a normal value for any regen. So next, we're going to do something the hard way. I'm going to go in there and attempt to trace all of the wires and draw the schematic, because I do not have a schematic of the set. I've found similar sets, but this is obviously a unique radio, and I saw no sign of it online. You'll notice that inside there are a bunch of fasteners. Some of them are types that can be turned by hand, like on the tube sockets. Some of them have screwdriver slots. All of those connections should be loosened and tightened, preferably with a little bit of contact cleaner. Every single connection on this radio has been sitting there for, almost 100 years, and we can't assume that we have good DC connections on all of those. So we're going to need to loosen and tighten all of the connections. Also, during this tracing, I'm going to be removing the tubes and putting them in a safe place, because I don't want to accidentally break any of the O1A style tubes. I'm looking down through my mag light, and I can see that the tube socket is marked. I'm not sure if you can see the markings. It's not like 1, 2, 3, 4. It's like grid, plate, X, and ground. So, or minus. So the lower left at 7 o'clock is the minus. And at 5 o'clock we have the X. That means that's the power, the DC power, positive filament. And then the upper right at 11 o'clock we have the grid. And then finally at 1 o'clock we have the plate. So the tube sockets are marked. This is going to make my job a lot easier. So I have pretty much figured out the receiver schematic. It's very similar to a Crosley 52, and I worked out what all of the posts in the back of the radio do. So I think we're getting close to being able to power things up. Now, these radios require 3 power supplies. They require an A battery. The A battery is what lights the filaments of the 3 tubes, and that traditionally was a storage battery, a 6-volt storage battery. And then they used a rheostat to lower the filament voltage as the battery was 6 volts, and we really need 5 volts. And then as the battery went dead, you'd turn the filament up, and it would allow the battery to supply the proper voltage to the tubes through its whole discharge cycle. So that's the A battery. For the A battery, I'm using my power supply. That can supply several amps, and we don't need very much. Just need about 5 volts times 3 tubes. Next, we need the B battery. The B battery in this radio is really 2 batteries. This particular Crosley needs 22 volts for the detector and 45 volts for the 2 amplifier stages. That's pretty modest, actually. Again, notice how the detector is running on a lower voltage than the amplifier. I didn't make that up. This is the way they've done it for years. The regen operates a lot better on lower voltage than the amplifier stages. So I was using 24 volts on my radio. Here they want 22. I'm going to operate this thing on 24 or 25 volts. And on the high voltage, instead of 45 volts, I'm going to use just about 80 volts because I have a little power supply that puts out 25 volts and 80 volts. Now, it also puts out 6 volts, but not enough current to light up these tubes. So I'll just use the 25 volt and the 80 volt. The third battery it needs is for biasing the stages on the grid of each of the audio amplifiers. The detector doesn't need bias because it makes its own with its grid leak system. But the amplifiers being transformer coupled and no grid leak bias at all, no cathode, or in this case, filament bias, you have to supply external bias, usually -2 to -3 volts for this voltage range on the O1As. So I'm using a pair of AA batteries, so it's going to give me -3 volts on the grids of the 2 audio amplifier tubes. The output simply comes out this jack on the front, and that's where you'd put your headphones in if you had 2000 ohm headphones. Or in my case, I'm hooking up a transformer that's going to feed the speaker. Let's do some quick voltage checks. Be a good idea to check out the plates of the tubes. See what we've got here. Here's the negative. Let's look at the plate of the audio output tube. 81 volts. Plate of the first audio amplifier. 81 volts. And the plate of the detector. 25.5 volts. Okay, so that's good. Next, let's try to check the bias. We should have negative voltage on the grids. Grid of the audio amplifier output, -3.1. Grid of the other audio amplifier, -3.1. And on the detector, nothing, because the bias battery is not connected to the detector. Finally, let's check the filament voltages on the tubes. Here's the audio output. 5.6 volts, and this is unloaded. 5.6 volts. 5.6 volts. So I'm not sure if you can see this or not, but the 2 audio amplifiers are glowing. So let's measure the voltage across them. Okay, first let's verify our input voltage. 6.13 volts, okay, so that's what we're putting in. And now we'll get across one of the filaments, and it's 4.36, a little bit low. So what we're going to do is we're going to turn this rheostat over here. I'm going clockwise and it's actually going down. So I'm going to go the other direction. With the rheostat. And there we are, 5 volts. Okay? So we use the rheostat to bring the voltage of the 6-volt battery down to the 5 volts to light the 2 tubes. Now they're very happy. Okay, I just plugged the detector tube in. I do not know what the number of the detector tube is. It could be similar to the first amplifier tube, or it could be a UV 200. A lot of times the 200 was used instead of the 201 because it has lower mu, and it would work better in a regenerative system. So they actually thought like that, using the right tube for the right job even this early. So let's look at the filament, see what we got across it. Only 3.6 volts. So we need to adjust the detector's filament voltage as well, and that's done with a separate rheostat. And they were pretty smart. They put that rheostat on the front of the set. It's here on the front of the set. So that's where we're going to adjust that. So let's try to get across there without causing a short. Let's see if that actually works to affect it. Here it comes. Okay, beautiful. And now he's lit up as well. Why do we need to independently adjust the filament voltage on the detector and the 2 audio amplifier stages? Basically, you could put the detector into a condition where the regeneration and the detection was the most linear, or the smoothest, based on the emissions of the tube. And you had continuous adjustment of that with that filament control. So we've got all kinds of control here that we're not normally used to using with regens. We're controlling the emission with the filament, and with this control over here, we're adjusting the feedback with a varicoupler. A varicoupler, what's that? A varicoupler is a device that allows you to change the coupling between 2 coils. Variometer, what's that? A variometer is a different device. That allows you to change the inductance of a coil using the same principle, but it's a single coil, not 2 coils that you're coupling. So when you hear variometer, sometimes they mean varicoupler. Very similar words. So I love a smoke test as much as anybody, and I have not touched anything. So we're just going to flick the switch on the B+. Let me tell you, this is a good sign, isn't it? This is the first time I've ever had this radio on, probably in the 20 years that I've had it. I just flick the switch.
If you have questions about voting, get the answers you can trust from your supervisor of elections.
So, the dial doesn't look like it's right.
those experiencing hardships due to the coronavirus outbreak. Visit WBZ1030.com/United Way for more information. And remember, we're all in this together.
Sports now on WBZ News Radio.
Political role of women.
Technically telling the legislative branch.
Don't talk to me like that. Nobody's talking to you.
Seen past presidents, when they go into that first debate, they flop. The famous example would be President Obama going against Mitt Romney back and forth.
Gary, we were talking earlier about some of the macro influences here, but it's worthwhile to remember that Romney back in 2012, the first debate was a disaster.
I was introduced to Joe Biden by Jim Biden and Hunter first.
No, but and I say simulates because you just can't beat. I really miss.
So I think we can put this baby back up on the shelf. It's proven that even though maybe it's been sitting around for 50 or 75 years without being used, that the parts in it are top quality. Even the tubes still work. The mismatched set that was in here, the tubes work perfectly. Hope you've enjoyed this little fire up of a original 1920 kit radio.